Cast Iron, I believe. No, it's called Casino Queen.
Who's a cowboy? It is cowboy. You're a cowboy. Oh, it's a Will Smith song. No, that is. No, it's not.
Okay. As always, we begin with a review of what we already know. 3 squared is what? 3 times 3. Yes? Excellent. X squared is what? X times X. Fish squared is what? Fish times
Fishes.
Fish. Which gets you a school. That's why you're so smart, because you all are fish. Why are we fish, Mr. Myers? Because you're in school.
My mom thinks fish is not have feelings, so she eats only fish and she doesn't eat any other animal.
Fishes.
She's afraid herself a vegetarian, but she eats fish.
You know, I gotta tell you, it's super hard to grow fish because they require a lot of water. All right. Huh?
Oh, okay.
Because a great many vegetarians consider eating fish to be okay.
Mr. Myers.
Because obviously fish are vegetables, like peas and corn and kale. They're not. What?
We have 2 fish tanks, one in the, our first floor, and one in our basement. There was lots of fish in there. There was like tiny fish and big fish. And then one time, we had a big fish. It ate all the other small ones.
Yeah.
And then it died.
That happens.
And now we have 0 fishes.
There was an excellent story that I used to have read to me when I was a little kid. I can't remember what it was called. But a kid goes to the pet store and he gets a fish. And the pet store owner says, here's the fish food. Now remember, never more than a pinch of fish food a day. So he feeds the fish its pinch of food, and then he says the fish looks sad and hungry, so he gives it some more. Then the fish starts to grow.
It's a magic fish.
So it grows and it grows, and it grows out of its little fish bowl, so he puts it in a mixing bowl. It grows out of the mixing bowl, so he puts it in a bucket. It grows out of the bucket, so he puts it in his parents' car. And it grows and it grows and it grows and it grows. And eventually they've got a crane, and they're putting the fish into the local swimming pool. And then they finally call the pet store guy, who shows up in scuba gear, and he goes into the pool, and then the next page.
What?
Yeah, see what I did there? I know spoiler alerts here. Not telling you.
I know what happened. We're never going to read the book. Where's the book? What's it called?
If only there was some kind of repository of all the information in the history of humanity.
Google it.
Where's my phone?
So, we're all...
I know what happened.
No.
I do what? This is gonna happen.
No.
So the scuba diver dives in, eats all the go inside.
It wasn't a Curious George book. It was before...
All
right.
Eat up all the fish.
So, now guys...
And then he's gonna eat it.
Why did I do something so silly as to square a fish? What is the mathematical point of that? Of course, the social point was to make a joke, because that's what I am here for after I've taught you math, is to keep you laughing. But I am making a mathematical point here as well. Blake, what do you think my mathematical point is? that everything is exponent with an exponent is that times that. It doesn't matter what letter it is. It doesn't matter what symbol it is. It doesn't matter. Because nothing bothers me more than a kid saying, I can't do that math, Mr. Myers. We just did that math right there. Yeah, but you used N, and now I have to use Q.
Oh my God.
I can't do it now. Now you think that that is not something that happens. And yet, I've had to invent this. So how often do you think it happens?
Oh my God.
All the time. Okay?
Hey,
So,
you could technically do algebra, except instead of using a variable like n or something, you could use fish.
yes, I have done that in the past as well. Now, you guys are smart kids. What does an exponent do to its base? Yes.
Depending on the number of, like the value of the exponent, it multiplies the base how many times of the number.
All right. Kind of a cumbersome definition, but yes, he is right. What is a base? Carlin.
Bigger number and the number that you multiply the exponent by? No.
Not quite.
How much the exponent is small?
Getting warmer. Josiah. Anything that is to the left of an exponent is a base, and the exponent makes that base repeat. Right? Everybody understands that?
Yeah.
Okay. So what then is 3 squared cubed? Anish.
That'd be
3 to the power of 6. Why?
Multiply the exponent.
No, that's telling me what to do. I asked you why. Amshman.
Because there's a bracket around.
No.
Oh.
Leighton. Because it is 3 squared times 3 squared times 3 squared. Which is what? 3 to the 3 times 3 to the 3 times 3 to the 3. 6 threes, so it is 3 to the 6th. Now I'm going to stress this to you guys again because we are in the second unit and you guys still haven't made this distinction. I don't care if you know how to do something. I can teach a monkey to do math. I only care if you can explain why. Do you understand me? So, while Anish was absolutely correct right here, the next person that gave me the right answer was Leighton. And then the next person that gave me the right answer was nobody because I interrupted the 3 wrong answers that I heard at the same time as I wrote out the right answer. Do you all understand what I am saying? You have been given a free ride to now because you are all very good at understanding and seeing patterns. That's why you're here. Unfortunately for you, your math education, for a great many of you, has left out the why things work, which is a real problem when you get to higher level math. All right? You guys have been doing the same thing since the 2nd grade in math class. It's not your fault. Huh? It's not your fault, and it's not Mrs. Bagcrumble's fault. It's society's fault. Unfortunately, I cannot fix society from my one room. I can hope that the 30 kids I have every block times 4, 120 a day, times 8 for the year, I can only hope that all of you go out slightly better equipped to try to take society back. All right? So, that opens up the 3rd law. Now, bear in mind you're only in the 9th grade. So even though I say all this, you'll still be able to get through just knowing what to do. Okay? But every year it's going to get a little bit harder to get by if you only know what to do. Okay? There's a very big difference between what you do and why you do it. All right? And up to grade 9, what you do is often all anybody has ever asked you for. But it's going to start changing, especially for those of you that are planning to go into IB and or university, and not just math. Okay? All right. So the law is for what we call powers of powers. And that's when we have x to the a all to the b. And that is x to the a times b. Now remember, are we allowed to disregard all of our previous exponent laws? No, we're not. So make sure you keep that in mind. So, here I want two things. I want you to tell me the right answer by two methods. One, what it actually is. Two, using the law. Everybody got it? Go. What is it actually? I'll wait a moment for you to try 3A. Jack. That's using the law. What is it actually?
3.
Squared.
Yeah, 3 squared
How many times?
times 4.
4 times. Now, if you wanted to go one step further, you could go 3, 3, 3, 3, 3, 3, 3, 3. But now I'm perfectly happy that you go 3 to the 8th, because you know the law. All right? Look at B. B is slightly trickier. What is it actually? Amsham.
Negative 5 to the power of 3 to the
Negative 5 to the third, negative 5 to the third, which is
negative 5 to the 6.
negative 5 to the sixth. What is C actually? No, you already did one. If no hands go up, I'll give you a shot. Sam, what is C actually? Then what? Right, negative in front. So it is negative 2 to the what? 12th. Will this answer be positive or negative?
Positive.
Will this answer be positive or negative?
Positive.
Will this answer be positive or negative?
Negative.
Negative. Good. Now, do it again without me saying anything. Should take about 5 seconds. All right. So, of course, that is 9 to the 3 times 4, which is 9 to the 12. 5 times 3, which is to the 15th. 4 times 2, which is to the 8th. Gouda? Great. Review. 3 squared times 3 to the 6th. What is it?
3 to the 8th.
3 to the 8th. Why? Amshman.
Because you're doing 3 times 3.
3 times 3.
Times 3.
Then
and then 6 times.
6 threes.
Yeah.
And math guys are lazy. What's the shortcut?
7.
3 to the 2 plus 6, which is 3 to the 8th. What is it about this construction that allows us to do this shortcut? Carlin. It's cool. I didn't even see his hand in your back.
Huh? No, I do that.
I know. I'm aware. I'm just making fun. Barely saw Anisha's lips move. Anish, you can say answers too. Or do you just not think Carlin's got the right answer? You should give him a shot. Then if he's wrong, you can go, all right. But he's absolutely right. This only works because we have the same base. So, are there other numbers? Are there other numbers? Are those numbers allowed to have exponents? Can we perform operations on those numbers? Excellent. So what if I had this? 3 squared times 4 squared.
You can do that.
Yes, you can. You just told me I could do this.
No, not with the shortcut way.
There's no law, right? Different bases. So evaluates the only option. Now, how are you going to evaluate that? You can evaluate it in your head. Wait. 25?
No.
Try again. Alicia. Warmer. Alicia did what I said somebody in the class would do at some point. Alicia did 9 times 8. Because she did 4 times 2. Yeah, somebody does it in every class, Alicia. Don't worry about it. What is it really? No. Amsham. 144. Because it is 9, which is 3 squared, times 4 squared, which is 16, to get 144. Now, stop for a second. Can you see anything that is in common between our two factors? Taylor.
They have the same exponent.
Oh, Taylor, they have the same exponent, don't they? Which means, what is this really? 3 times 3 times 4 times 4, yes? So isn't that 3 times 4 squared? And isn't that 12 squared? And isn't that 144? Gouda? Great. So this is when we have, oops, I got to check something. What did I call the very first law? Okay. Now, the multiplication of powers comes in 2 different flavors.
Raspberry and chocolate?
Okay? There's 2 ways we like to do this. There is the product way, and there is the I'll change color. There is the, not that the colors really show up anyway, and there is the evaluation way. Okay? The product way is this. 3 squared times 4 squared times 7 squared squared. The product way says I would go 3 to the 4th times 4 to the 4th times 7 to the 4th. That is what we call a product of powers. Because I've kept the powers as powers. Good? All right. The evaluation way says here I would go 3 times 4 times 7 squared. You would do the brackets first, then you would square the answer. All right? So you would go 9 times 16 times 49 and then square the whole thing, which is 144 times 49, and then square that. It's going to be a crazy, gigantic number. Everybody understand? So first, let's just do that. Wrong calculator. That one's dead. 144 times 49 would be 7,056 squared, which is 49,787,136. Got it? So either you are evaluating the brackets and then applying an exponent if asked for evaluation, or you are doing the exponent to everything in there. All right? Everybody cool? Cool? Okay. So first we're going to do two very easy ones with it that aren't, there is no trickery, there is no jiggery pokery, it's just easy. Does this say evaluate or product of powers them? Evaluate. So the first thing I want you to do is evaluate. So what do? 2 times 5, which is what? 10 squared, which is what? 100. Everybody good? Easy peasy lemon squeezy, yeah? Now, product of powers. So what does it become? 2 squared times 5 squared, which is 100. Good? 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 Excellent. In black, evaluate. Evaluate. Right, because it's negative 12 in brackets, because the brackets are around all of it, squared, so it's positive 144. Now product them. Negative 3 squared. Why is the negative in brackets? Because it's part of the base, times 4 squared, which is 9 times 16, which we already know to be 144. Is everybody Gouda? Okay, now, I want to write something here that might be a little bit tricky. 5 plus 3 squared. What's the answer? Okay, now, is there any other way we can write it? So Carlin says it's 5 squared plus 3 squared, because which would of course be 25 plus 9, which is, which one's right? 64 is right. But why is this wrong when up here It was right. Because this is adding. Okay? You've got to keep your eye on that. If you memorize that an exponent outside of brackets just goes to everything inside the brackets, memorizing what you do, not what you are doing, then you can be in trouble, can't you? Because this makes perfect sense if you have memorized a step, not what is happening. Do you understand the problem? Everybody good? So watch yourself. Watch it. Because like Snapchat says, the clowns are coming.
No!
Jack, it's a joke. They're not.
What do you mean the clouds are coming?
There's these clouds on the internet that come around with knives.
Fix these up. Go. You've got about 5 seconds. Done. So, what's this? What's this? What's this?
That's 5 to the 4, 7 to the 4,
What's this?
8 to the 2.
What's this?
-1,
-6 squared.
Right, yeah. 36.
36. And this one?
4 to the power
Positive 4 cubed, which is
64.
64.
66.
Gouda?
Great.
Great. And exponent law 5.
Are we gonna have another quiz?
Your next quiz is after all the exponent laws, I believe. Oh, no. Another quiz is after these two. Because the next exponent laws are crazy.
was tomorrow?
No, it won't be tomorrow.
I'm not even
I don't care. I don't know how to explain this to you. I cannot explain it to you anymore. I don't care. If there's a quiz on Friday, it becomes your job to get it done. Okay? This isn't elementary school. All right? This goes for all of you. If you're not going to be here, don't be here. All right? 3 to the 21 over 3 to the 16th. What is it?
3 to the 5.
Why? What allows us to do that?
Because it's 3 times 3 to, 3 times 3, 21 times, divided by,
Because it's the same base.
yeah, that's it.
Okay? We already know that. 2 to the 4th, 3 squared. Can I do anything with that? Why? It's different bases. So different bases means what? What does that mean is my only option? Evaluation. So what is 2 to the 4th? 16 over what? 9. So you can all do that. But again, you need to be aware of a couple of things. Is there anything in common there?
The 4 and 2 are the same.
4, 2, 2, 3. Is anything in common?
No.
No. So, we're stuck. What if I gave you this? 2 to the 4th over 3 to the 4th. Now what do you have?
The same exponent.
The same exponents, which means what do you have? 2 over 3 to what power?
4.
4. Does everybody see that subtle difference?
Yes.
When they're the same exponent, we can do the same thing we do in multiplying. When they're not the same exponent, all we can do is evaluate. Everybody got it?
Yeah.
This is obviously division of powers. And again, it can be split into 2 different flavors. All right? You can have either 30 squared divided by 6 squared is either 30 squared over 6 squared, which is 900 divided by 36, which is 25. Or it is 30 divided by 6, all squared, which is 5 squared, which is 25. Everybody good?
Yeah.
This is evaluating. This is what we call a quotient. Quotient. Everybody cool? So I've said evaluate first. What do I do?
30 divided by negative 5.
30 divided by negative 5, which is what?
Negative.
Negative 6 squared to what answer?
Negative.
Positive 36. Now quotient it. That becomes 30 squared divided by negative 5 squared, which is 900 divided by 25, which we already know from the example I just did was 36. Now do the same thing here. Evaluate first. Where do you go? Five squared, which is what? 25. Now quotient. 20 squared over 4 squared. 400 over 16. 25. Cool?
Yeah.
Great. Fill in the bottom. Quotient of powers. So what is it? Yeah, it's 5. Over. Done. What about this one? Excellent. What about this one?
Negative 16 divided.
4, because it's negative 16 divided by 4 squared, which is 16. And what about this one? Can you do that in your head? What is it? What if you can't do it in your head? Where do you go? Calculator. 6, exponent button, 3 equals. Gouda? Great. Homework is page 83. Quiz. Even though sadly Sam won't be here Friday. Friday. Yes, Sam? Oh, I thought your hand was up. Have good days. That was almost perfect timing.
It was perfect.
It was pretty darn close.